With that, I'm Amita Sharma, and I'm managing OpenShift AI team at Red Hat, and I'm from Pune, India. I have my fantastic colleague with me.
Yeah, myself Arthy Loganathan works as a principal quality engineer in OpenShift AI team at Red Hat.
Yeah. So today, both of us will present this topic: how you can build and operate smarter AI application with the help of Open Data Hub. The topic will cover that why we should really care that AI and ML workflows should be open source, what are the challenges exist, and how we can solve those challenges, and then that will be followed by a demo by Arthy and question answers. So let's dig right away in. Uh, to wake you up a little bit, I would like to ask a question from you. I'm sure all of you are using a AI application in some or other way in solving your day-to-day problems. May I ask any one of you to give me one example that how you are incorporating or using the AI in your life? It'll be great if that example is a little bit interesting or unique. Anyone, please? Come on. I'm sure somebody can give very simple example that how we are using AI application in our day-to-day life. Anyone? I'm sure you are present in the AI track. You can give me one example. Have you ever used ChatGPT? Any one of you? Just raise your hand. So yeah, that's the simplest example of using any AI application. So in our observations, we use AI application in getting the answers of the questions. We also use Bard sometime to generate AI images. We use AI systems to generate codes. We use them to plan our trips. And not only that, we draft our mails sometime by using AI, right? So we can see and we can say that the consumer base is increasing of AI application, and the adoption is also increasing with the confidence. Whether it is ordering a coffee to a robot or accepting the driverless car, the market is increasing day by day. To tap on these opportunities, all the industries and everybody wants to build their unique solutions with the artificial intelligence, right? So if the consumer is ready, market is ready, the industry is ready, what are the challenges? Why are we lacking behind? Let's talk about and understand the challenge. Okay? I would like to give you an example, a very woman centric example: chef, though it is representing a male figure over here. So just imagine you want to set up a restaurant, a food business, okay? And you have the best recipe in the world. You have all the ingredients and you have the best chef in the world. But you don't have the right tools and the kitchen to make that recipe. Then your business will not be able to flourish, right? Similarly, even if you have the best idea in the world to create an AI application, but you don't have the right tools to create it, that solution will be of no use, correct? Moreover, operationalizing an AI is not trivial. There are many stages to it. I'm sure you must be hearing a lot of buzzwords since morning in the AI track, and they all make sense. Whenever you want to develop an AI application, you need to decide what is your goal, what is your objective. Accordingly, you need a model, right, which can be consumed by your AI application. You need to train that model, and the amount of data required to train such model is huge. It's among us, right? And then you need to train your model on certain parameter, deciding those hyperparameters so that your model can accurately generate the output. That is also not an easy game. and then deploying your model and utilizing your model by your AI application. The story doesn't end here. You need to continuously monitor your model, whether it is accurate or not. If anybody has used Bard over here, you have seen that it generates 3 or 4 answers, right? And it corrects itself, it fine tunes itself with every question asked, right? So that monitoring and correction is also required in the life cycle of the model development and AI application. So the point here is it's all very challenging and complicated. To add to it, when I mentioned about the data complexity and the amount of data needed to train these model is huge, and such kind of data is controlled by some hypervisor and tech giants in the world. I don't need to name all of these. We all know that they capture our data in exchange of free services, and that is why they are the central owners of such huge data which is required to train any fair enough model, right? To add to the list of challenges, this will be the most interesting one, and I'm pretty sure many of you might not be aware about it. We all know that for developing the ML model, ML workflows, we need GPUs, CPUs, computing power, high resource computing powers, and all. But um, this is something actually so much interesting that everybody talks about DI compliance in AI ML, right? And I'm fan of it, by the way. I'm not against of it. And I really wanted a women's photo also in the slides which Harish Pillai has presented today morning, and it has all the men in that slide. So that is one thing about data filtering and not being biased. But there is also a very important factor when we are developing the AI ML, that is impact on the natural resources. Have you ever thought that chat GPT we are using in our day-to-day life, it consumes at least 1 liter of water for every 15 prompts? So every time you are asking 15 questions to ChatGPT, it consumes 1 liter of water. So how many gallons of water the ChatGPT model must be consuming? Now you must be thinking how it is relevant, the water consumption. Electricity makes sense, data servers make sense, electric garbage, carbon footprint makes sense, but water, it seems irrelevant, right? But if you know, I will be interested to know from you. If you don't, I'll be happy to answer in Q&A section, because this is not the topic for today. Now I have presented the challenges. The answer lies in open source. I will not leave you alone with the challenges. We will dig into the solution, which is open source. And I have my friend and colleague with me to take us further in the Open Data Hub, which is our solution for these challenges. Over to you, Arthy.
Thanks, Amita. So, for the real world challenges that Amita speak in the previous slides, we have one-stop solution that is Open Data Hub. It covers 3 personas: data scientists, app developers, and AI applications. So, as a data scientist, uh, what we want a self-service like experience for the machine learning projects, so where you can access a rich set of modeling frameworks, resources, and share and collaborate with others, and delivering the work into production with speed, agility, and repeatability to drive business value. So some of the challenges that data scientists face today is they are all working in their own isolated environment. So it is very challenging for them to collaborate their work together in kind of mode that they develop and with limited resources. So how do we overcome these challenges? ODH allows customers to build, deploy, monitor AI applications at scale. What we make it different is that we help customers to bridge the gap between the data science initiatives in MLOps world and the application development world. So it can go hand in hand. to accelerate for getting the models into production and train and serve the models to AI applications. So, ODH is an open source platform for foundation models. It supports many infrastructures like physical and virtual environments, private and public clouds, and it is built on top of Kubernetes. As a data scientist, you can take the models from Hugging Face, that is an AI community, to create tools and models for the AI applications using machine learning. You can take them and train and deploy them into the AI applications at scale. Now, let's see how we utilize ODH to create, build, train the model, and to integrate them into a fraud detection application and refine the model using automated data pipelines. Let's experience how ODH looks like. You can install ODH from the operator hub, and once installed, it will be visible in the installed operators page. The components of ODH are workbenches, data science pipelines, and model serving are present in the data science cluster details page. And parts of each of these components are under Open Data Hub project. Now let's see how the dashboard of ODH looks like. So this is the data science project where you can organize all your work together and you can start your experiments. So this is the dashboard that Amita speak in the previous slide, and this is the kitchen in which you can cook all your AI recipes. You have workbenches, and you can connect to the external object storage using data connections and run your pipelines and serve the model to the AI applications. For this demo, I have used Miao as our data store, and I have created two buckets, one for fraud detection model to store that, and another for storing the pipeline artifacts. Now let's see how we can create the notebook image from ODH dashboard. So for this demo, I have used TensorFlow image and have connected the object storage that we have created before. And once the notebook is launched, we have this page and you can clone your code repositories into it. I will explain a bit about the dataset and model that we have used for this demo. This model depicts the credit card transactions for potential fraudulent activities, and it analyzes the transactions based on the geographical distance of the user's transaction and price of the current transaction compared to the median price of all the users transaction, and how the user has completed the transaction, either using pin number or hardware chip or using an online form. Yeah. So next, we have used sequential model from Keras library for the fraudulent model, and we have added layers on top of it. This is a deep neural network, and it consists of 3 hidden layers and 1 output layer. Let's build the model, and after training it, we can, as a data scientist, we can always test the model. And for example, I have asked whether the Salis transaction is fraudulent or not. The model gave me 0.0080. So whatever the value greater than 1 is considered as fraudulent, and whatever is less than 0 is considered as not fraudulent. So it is trusty one. Once we have tested the model, we can then upload this model for future use in the Miao bucket. So I have stored it in the ONNX format. So now let's see how we can use that model from the data storage and serve it to the AI applications using ODH. For that, you have to use the model serving option. You have to mention the model name and the serving runtime. I have used OpenWindow model server here. Once it is done, you will get the inference endpoint. And using that inference endpoint, you can always integrate it to the AI applications. For example, here, I have queried the model using gRPC requests using the inference endpoint, and I got the same output. The transaction is not fraudulent. And we also have Elira plugin to integrate the Jupyter notebook with the data science pipeline. It enables data scientists to visually create the end-to-end AML workflow using the pipeline visual editor. It consists of one or more nodes by defining the execution dependencies. For this demo, I have used two nodes. The first node is for creating and building the model, and the other one is for saving the model. And I have defined the execution dependencies on the right side pane. And while execution, you have to select the data science pipeline so that while running, you can always go and analyze the logs in the backend, I mean in the ODH dashboard using the pipeline run section. And also you can see it in the backend cluster. Yeah, so all of this with ODH, workbenches, data science pipelines, model serving, different technologies are rolled out into a nice deployable package for customers. We are continue to release more technologies to round out all the end-to-end AI ML workflow. Thank you.
Yeah, so you have seen that the life cycle which I showed to create the AI application. It is nicely presented, and all the tools are nicely integrated in the Open Data Hub. You can use all of those tools to create and generate your AI applications. We are also working to increase the amount of tools we have currently in the Open Data Hub, for example, for the distributed workload, because you need to train your model in such a fashion that it has a lot of training jobs, tons of training jobs, and you need to distribute your workload so that the amount of computing, the cloud computing it is being utilized should be minimal, because costing is not less, right? And then hyperparameter tuning is something else we are working on in future and determined to deliver that. Currently, I think we have approximately more than 20, around 20 plus open source tools integrated in Open Data Hub and provided to all of you. So if you would like to join us in this journey, you are welcome to find us in the GitHub link. The slides will be shared. And then there is a Slack channel. You can join us in there. If you have any questions, please go ahead. Thank you so much. So everybody knows how ChatGPT drinks water when we when we query it. Can somebody tell me? I am also interested. Yes. No, no, no. It is open. Yeah. We have Red Hat OpenShift AI, which is the downstream product of the Open Data Hub, but Open Data Hub is the upstream for that. Yeah. Yes, it does. I'll let Arthy explain.
Yeah, we do support LLM models. So right now we are storing it in the S3 bucket, but we do have support in future. Yeah.
Any more questions, please? Okay, that's all then. Thank you.
Yeah. Thank you so much.
First time to FOSSASIA. First time. Oh, quite a lot, quite a lot. Okay. So I've done FOSSASIA for maybe like last 7, 10 years maybe. Just in case you want to catch the presentation. So we do record them. Actually, they're live stream, but after the event, uh, they will also post the video on the YouTube channel. So if you go to YouTube and look for FOSSASIA, you can find the video presentation. But give it some time because there's a lot of video and they need some editing. So be patient, wait a while, and you can actually watch all the presentations on the YouTube channel. So not to worry if you can't catch all the presentations. Maybe since we have a bit of time, I can introduce the next speaker, Hichem from Instacluster, and from France, I get it. Yep.
Yes, thank you very much. I'm really excited to be here. It's for my first time in FOSSASIA, first time in Vietnam. Yeah, of course, yeah. I just want to start by doing some publicity to our friend in Red Hat, Amita and Arthy. So go and check OpenShift AI. It's a really amazing tool. And we have recently a common joint support, Apache Spark support on OpenShift AI. So it's definitely something worth it. So yeah, there's a lot of technical words there. It was just to attract you into my talk. It's just nothing consistent in there. So yeah, about me, I'm an open source product architect in Instacluster. We are part of NetApp. Previously, I've done a lot of things around data. I hold a lot of position, data something, data engineer, data scientist, machine learning engineer, a lot of data stuff. So I'm talking as a practitioner. I'm talking about, I'm not trying to sell anything here. Just talking about like a real life use case here. Sony PlayStation, yes. We played a lot of games in the office. Yeah, I was managing an ML engineering team there. We built the platform, which was really amazing. At that time, I still had some hair. That's still gone. Everything's gone. Yep. So, and yeah, I did some graph theory at the time. Did a PhD in random graph theory a long time ago. So, the heart is not at the right place, but just a disclaimer here, there is no contribution to open source, any of the one that I'm gonna mention, but the plan is at some point contribute to the community. My vision of things is necessarily biased. So, my background, the company I work for, sorry, and stuff like this. And maybe I'll put my timer here, okay? And yeah, most of this is based on the kind of the principle of OSS and open data and like knowledge sharing. So it's really like in the spirit of sharing pretty much everything, and you will see a lot of things. And not machine learning, but human learning is a lifelong, work in progress. So it's always work that we need to kind of do better. Okay, the agenda for today, a lot of things here. We go through a lot of things, but there will be no definition, no mathematical equation, no code at all. It's just to show how we can, using open source, solve a real life problem. Okay, quickly, what is the real-time machine learning? Okay, machine learning, you guessed, smart people sitting behind their MacBook, writing, some Jupyter, and yeah, that's an amazing model. But what is real time? So that's the whole thing, and I'm trying to show it here with a real life example. A smart, a wise person said, the open model of sharing is a foundation for a better future. And I let you read. This was from yesterday, from Mario. So I was really lucky to, I just took a picture from his slide. So you see, we can use technology to produce locally more environmental friendly and more healthy. This is what I'm trying to solve here. So after the COVID, at least in Europe or in France, a lot of people start cycling to the office. So you guess this is where I live, from the other side of Paris, and I go to the office and I start every morning trying to cycle. It's nothing like Hanoi. It's nothing like this. It's way different. and just, So the thing is, how do I get the fastest cycling route to the office? That's just the first question I ask. The least traffic. I want to avoid traffic, okay? So you go out there and you say, this is like something obvious. It's probably solved already. I went to, I don't want to name the app, which is, by the way, the best we have so far, at least for cycling. And I end up in parking lots, accidents, and closed roads. So, okay, we have recommendation system for the next product we buy, the next food we eat, the next movie we want to watch. But how about, like, having something that impacts me and you? You want to avoid traffic, you want to go somewhere in like healthy way. This is something like still challenging. So yeah, I mean, one of the main thing here is like when you are cycling, you're doing exercise. So you don't want to breathe all this toxic or these polluted, particles. So where do we? I went to the academic world, and by the way, there were some like really cutting edge research, and especially more recently, India and China. A lot of researchers from India are doing like a really great job because it's becoming a really serious kind of health issue. So that's why like researchers from all over the world, especially here in Asia, are trying to tackle this problem. So academia is great, but still it's in the papers, so it doesn't scale. We have some guidelines on this, but not necessarily enough to build a product around this. So, and here we add the real time because, I have an hour cycling from my home to the office. A lot of things can happen. Accidents, I know, just think about all the things that can happen. So I want to get like recommendation real time based on the events that are happening. If there is a road closed somewhere, I need to get this information. Okay, like if I don't know if you heard, let's name it, like this navigation system called Waze, which was acquired also by Google. It gives you information about road closures and stuff like this, but it's based on crowdsourcing. So me and you users, we need to put the information. So we are far from there, at least for cycling and pedestrians and whatever, like So, but there is no kind of obvious solution to do this. Okay, so the only definition here, no textbook definition, nothing. So real-time machine learning, in this case, is the ability to generate prediction or recommendation or decision based on kind of adapting to the changing environment. This is the key thing. If you want to get somewhere, if I want you get out from my talk here, just think about this is like the only definition, as I said. So it's a box somewhere. We put all the information, weather, pollution, like road traffic and stuff like this. Put it in that box. Hopefully not a black box. We want it to be a white box so we can understand what's happening there and give you a recommendation or give you the best, route to get from point A to B. Okay, so this is what the platform look like, or at least, the goal is to put there the minimal kind of, stack that will help us to tackle this problem based on open source, mainly open source with different licenses. We can argue here like, this is not completely open source, this is blah, 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 blah. But the target is like, bring all the open source, put it together. Again, as I said in the beginning, I'm biased, so you probably list other tens of tools. I choose this, you can choose others, do benchmarking. This is not something vyas something. This is just how to put together tools to solve a problem. And one of the key things here is to use Spark or Kubernetes. This is how the title, because it's a building block for different parts of the platform here. The data ingestion, transformation, machine learning, training, and even, you know, like serving, but this is not something I mentioned here. Okay, so what are the challenges for real-time machine learning? Ship, she is, sorry, originally from Vietnam. She wrote a lot of books in Vietnamese, but not technical books. But I do for publicity for her. Designing machine learning systems is like an inspiring for me. She listed all, you know, this kind of, you know, challenges or key things to consider. And I think the blue one are like more from the data science side, sorry. I don't want to minimize or anything. And the other side is like more from the platform or from the tech stack, okay? So I cannot agree more with her that the real-time machine learning challenges in our experience and all the practitioner experience is mainly an infrastructure problem. It's mainly tooling problem, how you stitch together, how you bring together, how you build your platform. Again, I'm not minimizing all the cutting edge stuff that are happening from modeling side, but the main problem if you want to build something is around, you know, tech stack issues. Okay, so Spark and Kubernetes can help us do stream processing, training, scalability, and latency. Latency is the key. And resource efficiency, because as Amita was saying, we don't want to burn liters and, you know, kilowatts of electricity. We want to minimize the work we are doing because we're thinking about the environment after all. Okay? So just quickly, why Apache Spark? Apache Spark is a big data framework. It's in the Apache Foundation software. We use it. It has two green things. It's versatile, easy. You can use it with different language framework to do ETL, ELT, real-time machine learning, BI. And it's connect like, you know, to different object store, Kafka, whatever, just listed. Fast here, it's in the gray area where there are other frameworks, you know, that may be faster for other stuff, but like the green light here is enough. Spark on Kubernetes has been a long-going journey, but it's maturing enough. Kubernetes is in the CNCF, in the Cloud Native Foundation, but it has been running perfectly. And this is what we recommend. One of the key things here, I mean, there are a lot of benefits of running Spark on Kubernetes. One of the key things, it's the isolation and the resource management, which we consider as being like, you know, major thing here. If you are embarking or if you are starting, think about operators in the Kubernetes world. There are operators that make these applications run natively on Kubernetes. So there is a Spark operator there. We are really happy to contribute to this open source project. So yeah, if you want to test it, go ahead with the Spark operator way of running Spark on Kubernetes. This is not, you know, I'm talking about this. This is not just like our friends from AWS made this, you know, study. It's not just like the new hot topic. You know, as engineers, we like to use the latest, like, you know, no, this is a really serious because it brings some value, it brings performance, cost. So, you know, a lot of benchmarks out there. So really encourage you to check this out. And this is, again, as not like yet another hot topic. So what are the challenges? Let's come to the meat of the talk here. So running Spark on Kubernetes seems like an ideal, perfect idea, but there are some challenges. So monitoring, scalability, latency, and model training. I'll just give you some pointers here. Of course, as I said, I will avoid anything, you know, too tech here. It's just to give you ideas. So it's at the tip of the iceberg. Kubernetes is complex. Spark is it's complex too. Bringing together, you multiply the complexity. So the first thing is logs, and there are logs, tons of logs. And one of the key thing here is that you're looking at the key information, they are buried under tons of others. So this is, I list a few things here. How do we solve them? Of course, there is a rich ecosystem, open source ecosystem, design the monitoring, use something like Fluentd, Fluentbyte, Logstash and Prometheus. Prometheus kind of, helps a lot on this because there is a built-in Prometheus with Spark. So collect the logs and, change the paradigm, because we used to do this, monitoring just to kind of, find out that bad things happen. But monitoring, when you kind of change the paradigm, monitoring is more like, to be more proactive, helps you to prevent things from go wrong. And also we learned a lot of things. We learned things about how do we optimize our infrastructure? How do we kind of, misallocation and misutilization through the monitoring. Scalability. So again, it's not, you don't get scalability. It go back to like, I'd say common sense. How do you cluster? How do you size your clusters? How do you choose even the VMs or, like the machines, whether you're running this on-prem or in the cloud? How do you choose them? Dynamic allocation is a concept in Spark, which is like, too technical here, but it's a really key. And then just shuffle data is the data that, moves from one worker to another in distributed system. So scalability, the right sizing again, I'm just listing here a few points here, but one of the key things that again, Amita, I think mentioned, CPU, your training model, you're inferring, so a lot of GPUs, a lot of CPUs, there are smart ways to, ask our nice data scientists not to burn only GPUs. Like, even if you are doing deep learning, doesn't mean you need only a fleet of GPUs. You can have a mix, workload between CPU and GPU. And this is what's really great with Kubernetes. You have like affinity groups where you can mix workloads. So this is things that, take in consideration. And this is like, not say easy, but it's feasible with a lot of effort. Yeah, so I think I'll skip this, but dynamic allocations allow you to do like auto scaling. I mean, there is the auto scaling concept in Kubernetes. There is the auto scaling, concept in Spark itself. But anyway, this is something you have. This is really challenging, and I guess this is not solved yet. It's out there in the community, at least on the Apache Spark side. So this is a work in progress, but I would say, the main recommendation is be careful with this. Shuffle data is how do we manage, this external shuffle data. So a lot of big tech companies are working on this. Oh, you can't see the last one here. It's from AWS, but yeah, sorry. So the least, I mean, we can recommend again, like in unbiased way, we've tested the IBM Spark S3 shuffle data, which works perfectly so far. Latency, again, if you think about it, I mean, some of us who did like computer science a long time ago, we used to have at least learned this, the latency number every programmer should know. So it goes back to, how do you, things like, milliseconds, network, and stuff like this. This really matters, like, it's old school, but brings back to, if you have a pattern like, your data source, Kafka, Spark Kafka, it comes to things like that. You have to take the pen and paper, and figure out how you can reduce the latency and where are the bottlenecks, like old school fashion way. So yeah, there's another concept of the stateful. So we need to keep all the states. So it adds some complexity, but it's solved recently with RocksDB as a state provider. ML training, again, I think Amita and Arthy mentioned this. If you take that, Apache Spark itself is a bit lagging behind. And after all, if a data scientist asks you for things like scikit-learn or, stuff like this, they are mainly built for mononode or like, for single node. So you have to think about ways to distribute stuff like this. I can mention Ray. Ray is doing really great, but at least in our opinion, it's not mature and versatile enough. Okay, so things like Harvard and TensorFlow and PyTorch, these things, they work pretty good with Spark and Kubernetes. There is, I mean, it's open source from NVIDIA. This is like the Spark Rapids, which is kind of really cool, like for ETL, distributing ETL on GPUs. Okay, there is another kind of key challenge here, just mention just quickly, is the native, the default scheduler in Kubernetes kind of lack or had these issues where you can get in a point where you have a starvation of resources for some of your workloads or jobs. So the community has been working on two kind of main solutions. The first one is in the CNCF, which is Volcano, which is pretty great. Actually, we have been testing this extensively. And the other one in the Apache Foundation, which is Unicorn. I mean, you can test them if you want to embark on this journey, but both of them provide what Joan, like as a resource manager, used to give. Conclusion and takeaways. Yeah, yes. It's again, from our experience, you want to do real-time machine learning, Spark and Kubernetes is at least the right choice for the building block, for doing all the heavy, transformation, native integration, best practices. We showed that, we can reach some good latency, scalability, you get it by default, and the integration with the rich ecosystem. If you remember, we mentioned Kubeflow, Feast, stuff like this, were already there. Yeah, so use the Spark operator. If you're back again in this journey, design and build your logging and monitoring. I would say before anything, but doesn't make any sense, but just keep it in mind that you need to do it. Keep adhering to the best practices from both worlds, and use the rich ecosystem. And just why, by the way, like on a note, I think it was mentioned, contributing to the open source doesn't mean necessarily like write Java code. You can write Python, it's better. Just kidding, but I mean, share your experience, go out there and write, your thoughts, your ideas, your challenges. Contributing to the open source is way larger than, again, just writing and be a committer to a code, and keep cycling. And this is what, again, took this from Mario. So there's a lot of copyright here. He said, let's start collaborate and solve global problems. Thank you very much. Yeah.
Thank you for the excellent presentation. I have two questions. First of all, do you have any use case for the Spark or Kubernetes already? And the second question is, do you think Hadoop is outdated for this?
Okay. The second one is a really great question. I was expecting this one. Okay. So there is this say, at least in French or English, you say like, the king is dead, long live the king. So, so it's like when the king is died already, you say there is a new king, so long live the king. So Hadoop is not dead, so we don't say that Kubernetes is replacing. You cannot imagine how many companies, big tech companies, are still using Hadoop. We're just trying kind of, using the latest approaches like the cloud native, more containers and stuff like this, which Hadoop was lacking and it's still lacking. But all this rich ecosystem, some of it is coming from the Hadoop world. So Hadoop is still there. There are some still interesting use cases. I mean, one of the use cases that I was mentioning is solve this kind of problem, Spark on Kubernetes, like real-time machine learning, but a lot of like, again, tech or small or bank companies use Spark on Kubernetes. It was mainly built to do ELT, do extract, transform, and load. Just extract your data, transform it, put it in an S3 bucket, in a database, whatever. So this is something commonly used. You're welcome. You have any question? Yep. Yes. Yeah, of course. So you think Sorry. Yeah, the question was, yeah, thank you. It's about how to use framework like TensorFlow, PyTorch with Apache Spark, and what is the point, after all, to use this. So think about Apache Spark to distribute the work. Like if you have a model that doesn't fit on your machine or doesn't fit on the VM, you want to distribute this. You want to distribute your training. This is what we do. You know, at scale, like, you know, you cannot just run your model on a machine. So you need to distribute this. Spark has this, you know, like plugins, I would say, that help you to distribute the training on your cluster. So you have big cluster with different machines, and Spark help you to do this. So TensorFlow, things like PyTorch, we have a PyTorch operator. I don't know if I mentioned this, but you see that the torch distributor here, like, is it this one? Yep. This is something that helps you to use torch and distribute it on your cluster. So you don't have to worry or think about how this is gonna work under the hood. That's kind of, you know, in the nutshell, the usage. Yep.
You mentioned Ray was still emerging, so I want to understand where does Ray fit in compared to Spark?
Yeah, so that's actually, you know, something. Yeah, I repeat, the question is about Ray. Ray is really amazing, and you know, like, you know, Python based for mainly data scientists. I mean, it's emerging. It's really fast. It's doing really cool things. But I mean, again, just in my point of view, which is a biased one, it's not versatile enough. We want a tool. I don't want to manage, like, you know, multiple tools. I want a tool that can help me do ETL, ELT, streaming, machine learning in one thing, you know, in one approach. I don't want to manage like multiple of them. And by the way, there is a way to run Ray on Spark. So you can, yeah. So, but why add complexity again? This is a question to ask out there to the community, I guess. Thank you very much.
I can see all that cycling is making you very trim and fit. Next, okay, great. We have next up, we have Mr. Koji-san, Koji-san Annoura, he's a CTO of UTI Inc. And his topic will be mastering web application configurations, a journey through Nginx, uWSGI, and Flask with knowledge graphs. Okay, I can see a lot of people changing. So if you want to take the opportunity to stretch, do a bit of stretching because you've been sitting down for a long time, feel free to do so. We'll have a minute or two break to swap. Yep. Okay, so let's put our heads together to welcome Mr. Koji-san.
Hi, hello. Let's get started. And my session title is here, Mastering Web Application Configurations, blah, 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 and with knowledge graphs. Okay? Oops. Wow. Okay. Okay, who am I? My name is Koji Annoura. I live in Fukuoka, Japan. So I love Apache Hop. Apache Hop, do you know Apache Hop? Yes? Oh, great. Apache Hop is a data orchestration app. I'm a founder of Apache user group, Apache Hop user group in Japan. So, and I love Neo4j graph database. So I am one of the founders of Neo4j user group Tokyo. Please join us. Okay. Hi. I'm studying English on just Duolingo. Who is studying Duolingo? Oh, what kind of language? English or something? Oh, thank you. I learned English and Klingon. Do you know Klingon? Star Trek Klingon language. Yeah, over 3 years. Okay. Today's agenda is here. First, web app, about web app. Second, let's write a conf file, something. Third, one of the good solutions. Okay. Who knows about knowledge graph? Who uses knowledge graph? Okay, just one. Thank you. Oh, this is a big problem. Web server gateway interface. What is the correct pronunciation? One is micro whiskey. Second, uWSGI. Third, mu whiskey. First one, no. Second, oh, okay. Third, okay. I love micro whiskey. Yeah, like this micro whiskey. Okay. In Japan, it's called uWSGI in Japan, but micro whiskey is normal. So first on web app. Yeah, who loves conf or ini files? Who loves? No, loves. Hate. One is yes, or easy to set up, but no, difficult to set up. And no, what's I'm not sure of what's the best setting. Yeah, it's like RPG. You cannot achieve the goal in the attempt seek hint from the master. Okay. Oh, Python web apps here. So which framework do you like? No, Django or something? Are you Fast API? Oh, good. Yeah. This time I use a Flask. Okay. Please imagine you are a developer of Flask Python web API, a web app. So, and please imagine that you are also working a Ruby project. Do you like Ruby language? Yes. Okay. And most famous web framework is Ruby Rails. Okay. And oops. And please imagine that you're also working on the Java project. Okay. Python and Java is most common. Which framework do you like? The Spring something or Play framework? So I chose a Spring Boot. Okay, if you have 3 different language web app here, like this, how do you use access the website? Python port 5000, Ruby 3000, Java 808. Okay. Okay. This I choose one web server, so I choose Nginx web for web server like this. Okay. So in that case of Flask, it's common to use micro-whiskey. Okay, like that circle, red circle one. Micro-whiskey connects Nginx and Flask. Micro-whiskey option is has a lot of option, so difficult to create any file. So traditional problem solving method. One is seeking advice from experts, two, conducting web searches, three, using AI assistants like ChatGPT. For user ChatGPT 4 or 3.5? 3.5? No, 4. Oh, you're a rich person. Okay, let's write a conf file, any file for micro-whiskey with ChatGPT. Okay, just easy. Teach me how to connect Nginx and Flask. ChatGPT answers here. A simplest connection. This is Nginx conf file. I like this location here. Just a simple connection. Oops. So I ask next question. So how about using a micro-whiskey? ChatGPT answers here. And this line is changed up dot sock. Any file for micro-whiskey is here. Did you write any file for micro? No? Are you familiar of this conference, this any file? No? No? Okay. ChatGPT answers here. Okay, it's very simple ini file. Okay, I ask, yeah, okay. I ask the next question to ChatGPT. How do I automatically reload when the app changes? So they answered Pi auto reload. Please add Pi auto reload. Yes, it's correct. Virtual environment, it's not correct. ChatGPT answers here, Python path equal something. But, oops. Oh, wow. Yeah. Okay. Okay, yeah. Oh, it's hurting. And okay. Okay, what options should I add to my new setup? So I ask to ChatGPT, and they answered add a socket hyphen backlog option, but it's not correct. It's no socket backlog option here. Oh, that's five here. Okay. This is hallucination. Okay, one of good solutions. And how can one resolve hallucinations waiting for next version? Some GPT 3.5 or 4.5, 4.0, 5.0? No. It's good solution. One of the solutions is here, plus knowledge graph. A knowledge graph is here like this. Dog is animal, animal is living things. So cows is an animal. Cows eat herbs. It's a knowledge graph. So I create a knowledge graph. This is an example of a knowledge graph, movie and person. Matrix, movie, person, matrix, which matrix? This one? You can easy to search in cipher language. It's not SQL. Matrix movie, and the person is here, and Keanu Reeves, and Matrix 3. And this is a graph. So I put a micro-SK options to graph. Here, just category is 1 and type is 125. Option is 1254. So lot of options here. Okay. So you can add same as relationship. It's this option is different name, but same thing. And you can add check it relationship. So you set the disable logging true. So please check it log here. It's easy to set up and in the graph world. Okay, and this solution is Gen AI apps from neo4j.com. It's easy to write. Here, match. Okay. This Neo4j ways work with 3 different AI. Okay, conclusion. So really fast. The advancement of AI is remarkable, but knowledge graph is particularly effective for representing fact. Thank you.
Okay, next we would like to welcome, let me see, Ms. Zhang Lirong and Miao from Miao, is it? Okay, who will be speaking on opportunities to address complex challenges in e-commerce search through LLM. So, over to you.
Yeah, hi everyone. Thank you for joining our talk today. And we are thrilled to share you with the topic of opportunities to address complex challenges in e-commerce search through LLMs. This is our agenda of today. We will cover our LLM-based approaches from the construction of offline evaluation dataset to the innovation of phenomenon generation and our pioneering work on image quality assessment for satisfying user experience. Some brief introduction about our company. Mercari is Japan's top free market application for everything selling and buying. Our monthly active users are over 23 million, and there are over 3 billion items are listed in total. So making sure users can find what exactly they want isn't just nice to have, it's essential in Mercari. And for this purpose, we are addressing the limitation of what search can do in online shopping by leveraging the extraordinary potential of large language models. I'm Lirong, and here I'm with my team member Miao. We are both machine learning engineers focusing on making search results more relevant to users in Mercari. I will first kick things off with the first two topics today, and then Miao will take over from there to share our journey on image score. So let's head into our first topic today, the revolutionizing of the construction in the offline evaluation dataset by the help of large language models. As many of you might know, there are two critical stages in the domain of search, ranking and the retrieval. The evaluation purpose for each stage has distinct purposes and requirements. For example, in the ranking, the task is to reorder a set of given items. For example, in these cases, we want the clicked item to be ranked higher and not clicked item to be ranked lower. So the positive and the negative signals are both clear in such cases. Consider item got the user's interaction information as the relevant item, and those who didn't get the user interactions are irrelevant items. Also, the evaluation it's quite also relatively clear to give a proper evaluation on the ranking items. So anyone here can tell me which one performs better, the first one or the second one? Yeah, obviously the second ranking model ranked the relevant items higher than the first one. And in contrast, the retrieval task aims to improve both recall and the precision. So this aims to provide as much as possible relevant items, and this includes previously unseen items. In the meantime, we want to also minimizing the inclusion of irrelevant items. So the biggest challenge here, as you may appreciate, is how we evaluate on those unseen item datasets. This is particularly complicated in a second-hand free market like ours, because the inventory is constantly updating. The items in our marketplace is refreshing consequently, and our search systems are designed to prioritize newly listed items to encourage new sellers. So in the real search result page, only a few items got the historical information to help us judge the relevancy. And the large majority of the items are new, showing they don't have enough historical information to help us judge the relevancy. So as you can see, with the two retrieval systems, it's hard to tell which retrieval system performs better, because those unseen items, they could be relevant or they can also be irrelevant to users. And this also introduced us with a paradox. So we first want to ascertain item's relevancy before showing it to users. However, the relevance judgment inherently requires showing the data to someone. As a common practice in constructing the offline evaluation data sets, can be relying on the search logs or employing human annotators, but the method relying on search logs can face the unseen item issue, and the employing human annotators can facing a high cost and even the reliable issues. For example, one of my team members have faced the situations that the code workers he hired are relying on machine learning models to do the annotation. And besides that, there are recognition bias from person to person, and the complexity of providing the annotation guidance to the annotators. So, but with the showing of the large language models, this gives us new opportunities in constructing an offline retrieval data set. So our approach is inspired by some pioneering studies. One of the studies comes from the Microsoft paper, large language models can accurately predict searchers' preferences. And this paper indicates that LLM annotators can perform better in the annotation task than human annotators in terms of the cost efficiency and the accuracy. So based on this assumption, we developed a system to retrieve the potential relevant and the irrelevant items through our search logs and the semantic search. So item provided by the semantic search results, since they are retrieved by the semantic similarity between the queries and the item information, so they can be different apart from the lexical search. Those should provide us with the NC item dataset, and we then apply the GPT-4 annotation upon those NC item dataset based on the user's query and the item information that we provided. Those unseen items should be valuable to us for later evaluating on a retrieval system that improve recall. So this is how our annotation prompt looked like. At the top of the prompt, we first provide with the definition of each relevancy label. And there could be the exact label, substitute label, and the complement and the irrelevant labels. Following with several examples, those examples are established based on our real items in our marketplace. So this can help us, can help the GPT model to better understand the real situations in our marketplace. And then based on the user's input query and item information, the GPT-4 model will generate the relevancy label. And the definition of the relevancy label comes from the uWSGI dataset. We later also conduct the evaluation on the accuracy of the annotation prompt. The evaluation also conducted on the Amazon's uWSGI data paper, and our findings indicate a high accuracy across most of the labels except for the substitute label. And this exception addressed the limitation of large language models with complex judgment cases, such as situations that even human annotators find challenging. I would like also to share some real examples from the GPT-4 annotation. So for the query Amazon Fire Stick TV, the GPT-4 model considered the Fire TV Cube, Apple TV, and the PS2 device as irrelevant items to this query. And for the remote control of the Fire TV stick, it considers as a complement item to this query. And for the set with the Echo Show device, it considered this item as a substitute item for this query. So we can see a high accuracy from the GPT-4 output, and it was us to further explore the capacities of GPT-4 model on the annotation task. Okay, let's head to our second topic today, which is using LLMs on synonym generation. So synonym expansion is used to solve a customer's pain point, which is the disconnection between the user's keyword and the item they want to search. This hurdle is significantly heightened in Japanese free market because of the lexical gap between foreign languages and Japanese. So for example, here a user wants to search Louis Vuitton, and the item listed in Japanese katakana Vuitton will not be matched in this case. So to address this gap, phenomenon expansion stands out as one of the most effective solutions. So by expanding the phenomenons after user's query, whatever the keyword user choose to use, Vuitton, Louis Vuitton or English Louis Vuitton, they can be all matched to the correct items. And in Mercari, we also tried LLM-based approaches to improve our phenomenon generation process. In the proposing phase, we provide with the item titles, and GPT-4 model will give us the output of the source keyword and the target phenomenon. This is how our first version of generation prompts look like. At the top, we give a simple instruction on how to generating the synonyms, as well as a definition of what is the synonym. Following with several examples to make the model understand our expectations on generated synonyms. And our evaluation outcomes affirm that the GPT-based method outperformed all the other unsupervised methods that we previously utilized. And this improvement is not only in precision, but also in recall. So let's see a concrete example of the keyword theme-free. Significant improvement can be observed on both scope and the precision after applying the GPT-4 model on the keyword theme-free. And we also reached a significant improvement through our online A/B test. So encouraged by the promising outcome that GPT-4 generated phenomenons delivered to our business metric, we further explore the capacity of GPT model with the aim of improving the quality of generated phenomenons. So in our second try, we add a layer of filter by introducing abuse prevention rules into our process. And this is how our second version of prompt look like. Inside prompt, we define 11 abusing rules. And this goal is to make the model mindful of potential misuses or inappropriate associations that could occur in the phenomenon generation process. This approach requires the model to perform a dual function. First, to continue its original task to generate high quality relevant synonym pairs. And the second task is to evaluate on the generated synonym pairs to check if it's against the previously defined rules. So after the second iteration, we get a higher quality of generated synonyms, but still we found LLMs struggle to generate domain-specific synonyms. So for example, it's hard to let the model generate bug for the word purge. Those words can be crucial for our search system. So in our third goal, to further help the GPT-4 model generate exact synonyms, we use Google search, for example, to check whether purge has the same meaning with bag. We let the model to conduct Google search, what is purge, and then summarize the top result in the prompt. The model then can think it over to come up with the synonyms. This is an example of the keyword styling gear. The Google says styling gear is a silver accessory brand which established in 2000 year. And based on this understanding, the GPT-4 model then considered the styling gear as a valid synonym. But for the keyword bar accessory brand, it considers it as an invalid synonym. And later, we also conduct the evaluation on checking the quality of generated synonyms. So the negative samples are clicked from our first and the second iterations, mainly based on human checking and from customers' complaints. Based on our latest experiment, the newest dictionary only covers 0.93% of those negative samples. And compared to our very first synonym dictionary from the unsupervised model, there are only 3.31% of the false positive items can be found. So to summarize, we reached a better performance and more mature on each iteration of the synonym generation, and we gained a higher quality of generated synonyms compared to our traditional method. And I will hand over to Miao to introduce our image quality project.
Okay. Yeah. Thank you, Lirong. I will try to finish this part in 5 minutes. So let me first share the background of this project. In our Mercari app, only price and image is displayed in the search result, and we are considering the price and image can affect user clicks apart from the search relevance. For example, if an item have a better image, it may attract more clicks from user. So based on this assumption, we are trying to conduct an experiment to take the image quality into account for the search ranking. Yeah, and here is the overview of this project. First, for training, we build a training data set with the image pairs from the same search result page, and use reward feedback learning to train a model. And we deploy this model in the indexing stage by adding an image score to each item and index the extra field image score into the Elasticsearch engine. And at the retrieval stage, we use the image score from each item to as a factor to the Elasticsearch score. Since the original ranking from Elasticsearch is based on this score, we can use the image score to affect the ranking. Our today's topic is basically on the data generation. So let me introduce how we process this data. We use the search log from user query, stored our user query to get the similar items from the same search result, and filtering these items by price, so we can get similar items with similar price. And then we filtered them by the position, so we can get some limited batch. And we will send this batch to GPT-4 Vision API to get an image score. Here is how we design our prompt. So we are inspired by XIQE, which is a recent research on image quality evaluation. So we leverage the authentic evaluation part because it's aligned with our objective. Here's the prompt we used. We leverage a chain of thought strategy to encourage the LLM to first provide a task-specific analysis before assigning a score. This method cannot also not only get a more accurate score, but also provide explainable information. And we evaluate the LLM annotation by comparing with the pre-trained model for the image quality evaluation task. And the result shows that the LLM annotation has a distribution that better reflects the real-world scenario and also demonstrate the relevance to our user clicks. Here's some visualized example of low-quality image judged by GPT-4. So you can see there are some dark image or some blank image with only text information. And here's high-quality images judged by the GPT-4. And we also checked the trained the image score model on our LLM annotated dataset, and the result shows that also showed the correlation of a good result of the image quality and the predicted score. So here is a summary of our learning from our projects. And yeah, we think LLM label method is a good solution for a quick iteration or experimentation. So I hope this information is helpful for your task. Yeah, basically that's today's our sharing, and we're hiring. Thank you.
Thank you so much. In case you guys want to learn more, Bakari they do have a booth downstairs. So, or is it downstairs? Yeah. So feel free to go and approach them. Where's our next speaker? Ah, okay, cool. Let's try. You tried it already just now. Great. Okay. All right. Cool. I guess a lot of people are coming in to listen to your talk. A lot of people are coming in. or you can wait because that's the coffee break, and then we can test it. Yeah.
Okay, thank you. This is first time I come to FOSSASIA. Thank you. Okay, today I will talk about Gemma, a new open source language model that provided by the Google. Let me introduce myself. My name is Joan. I'm a Google developer expert machine learning from Indonesia, and I also a Google developer group organizer and TensorFlow user group organizer. And also I'm a lecturer and a director of Research Innovation Center at my university in Institute STTS from Indonesia. Okay, my research was in the natural language processing, machine learning, and knowledge engineering. So before we started to know about Gemma, we talk about what is an LLM. In the era of generative AI, LLM play a vital role models. LLM was a model which trained a lot of data that can capture a semantically or statistically pattern from the words. So it can be done for generated text or doing some things with kind of creative contents. Okay, let's look about in some example here. We can see about that the process of LLM. The simple example of LLM is about to have to create an autocomplete for several sentences that we created fulfill the blank. It says that if we look at it's rain, cats, and the LLM can say it's a dog. Also, it can use a reasoning here. Let's say Paris is from France and Tokyo is for Japan. But not all this have a great surprise for the LLM. The biggest surprise for LLM is also if we train our model into a poem, then it will be also created a response or it generate text poetic to complete the poem. And also when we train it into the code, and the LLM also can provide a complete completion of the code that we provided. Now, let's move to the modern LLM. If we say about the modern LLM, all the modern LLM is large. Why it is large? It contains a lot of knowledge that has been drained to the LLM. So if we look at this example for the some of the LLM example, a Gemini from the Google, if we look to explain this kind of joke, they can give us the detail of the meaning of the joke of the that we put as a prompt to instruct the LLM. And the second one, LLM also can give a suggestion to us to us a creative way to help us to get a better idea. Example in this, I provide into Gemini, give me 5 needs idea for science fair project, and the model can give us the example here. Now, due to the popular of the LLM, especially in the generative AI era, many research has been done in the LLM, especially also Google was released. The latest model on December was Gemini, and the last February is about the Gemma, the last open model that provided by the Google. Google has a long history in the open models and their ecosystem. Started in 2013. It was we know all about the word-to-vec model, especially we in the field of natural language. We know this model is very popular. And then in 2017, Google released the Transformer, which is state-of-the-art model until now that we created and use for developing some application. And then in 2018, Google released BART with the Palm app, and 2015, we released T5, 2022, T5X, and the latest open model that released by the Google is Gemma in 2024, last February. So let's look what is Gemma, okay? Gemma is a lightweight standard-of-the-art model. Surprisingly, Gemma shared the great recipe of Gemini. So if you look at the Gemma, Gemini was built using the same technology with Gemini, okay? So the Gemma has a 2 size that we release to public. That is 2 billion parameter and 7 billion parameter, okay? And they have a long context about 8K tokens, and there are 2 versions. There is the base version and the second one, the instruction tune version. And there are 2 versions in the size. There is 2 billion and 7 billion. There are several usage of this 2 type of size. The 7 billion is the use for the GPU or the CPU, and the 2 billion is for the CPU or on-device on-device training or on-device machine learning. What is special of Gemma architecture? The Gemma architecture was built in the transformer decoder architecture, and it's trained with a lot of context. That is 8,192 tokens that can be provided as an input to the Gemma. And for efficiency, the 7 billion model used the multi-head attention, but for the 2 billion, we use only the multi-query attention. This is the parameter table parameters that we contains in the Gemma. Gemma also use not absolute position embedding, but they use the rotary position embedding to have more efficient. And they use the share embedding between an input and an output to make model more compact. And also they replace the standard activation function ReLU with the K-glue, and each transformation was normalized by using the RMS normalization. This is the embedding parameters from the model from the 2 billion and 7 billion as a comparison. Okay, benefit using of Gemma as open source is we have a lot of community in Google. Also, they are provided in Hugging Face, in the Kaggle. There are a lot of people of use of Gemma right now, and we can lower barrier to the researcher and developer to get collaborate to develop a more advanced model from Gemma. And also, we can drive the faster, more innovation and collaboration between industrial and academic. And also, since this is an open model, we can examine the model and contribute to make it more better, and we can get trust by looking the model, since we can look the code as we know that Gemma is an open source language model. And also we can also tailor customize the Gemma to accommodate what we need in our company or our research. And we can explore more innovation based on this LLM. Okay, now what is the best of Gemma? Gemma has benchmarking in the academic and human evaluation. They are with the sharing technology of the Mini, they get best performance in the mathematics and coding benchmark, also the reasoning, compared with the open model, the other open model, and immediately accessible for the developer. They can run it into their own laptops, and they also can be used in the cloud environment, especially in the Google Cloud environment, with using the Vertex AI. The efficiency, yes, the Gemma doesn't need a lot of resource to run it. We can use our own laptop to run Gemma as our personal assistant if you want to deploy it as a chatbot model in our laptops. And also, we have provided safety and responsibility according to Google's strict AI principle to ensuring the safety of use of this model. Unfortunately, but we must, when we develop, we must adjust our model again, because even if Google already ensuring when creating the model by provide the data filtering and also the reinforcement learning feedback that create for training the model, we still need to adjust, because we cannot ensure that all the possibility that have been made when we use the Gemma. This is a table of benchmark that Gemma used compared to the Llama. We can see that Gemma surpassed all the performance of Llama. Building trust with Gemma. How safety is Gemma? Let's look. AI principle in Google. Gemma development has been prioritized by Google to use their AI principle to reduce the unwanted or unstable or unsafe issue by applying some of delta filtering. And also there are a lot of training and human evaluation has been done in the Gemma. We can look at detail and the Gemma report. And the data filtering also done by filtering the personal information or the sensitive contents when Google trained the Gemma as they prepare the data set. And also they use the human feedback to evaluate the model when they train the model, to ensure there are the negative or the unwanted situation is minimalized by this kind of training. And also there are race assessment. So Google has released a generative AI responsible toolkit to support the developer for creating the AI responsibility. We can look at detail on the model card. In the documentation, there are a lot of tests already conducted on the Gemma. Okay, now for the access. As I mentioned before, Gemma has been released into the Hugging Face and Gaggle. We can use several popular frameworks like Keras, PyTorch, JAX, Hugging Face to access the Gemma and to create the model based on our needs. And it also can run in the laptop, desktop, mobile devices, especially also in the IoT port to make on-device ML because of the efficiency of the Gemma. And it also, Google, when creating Gemma, was also partnered with the NVIDIA, and it is already optimized for the NVIDIA, start from the data center hardware until the local computer hardware. So it can be run smoothly in all the environment. And also if you have the Google Cloud environment, we can use Gemma in the Vertex AI seamlessly. So we can use the Vertex AI API to deploy, to modify, and to custom the Gemma model. Let's look at the example case that I've been done with my team. The first one is about, I want to try to create a question answering system with the Gemma only by using the instruction prompt model only. I do not do any kind of fine tuning in here. So The first one, I put it the prompt design that to have give an instruction to answer, to behave to my question answering model to behave like I want. And then I put some context and we can provide a question that then Gemma will answer based on the context that we give. We use the same Gemma 7B instruct model and we use the tokenizer. Surprisingly, the Gemma is created for English, but we try to maximize Gemma to another language. I try to use Gemma in Indonesian language in my hometown, and this is the prompt for the instruction. You are a role in a chatbot which name a talent tag. You are a chatbot for my campus, my university, ESTTS, and answer it very based on this context. Okay, if there are any question there is not in this context, please don't answer it. Okay, and this is the context that I given, some information about my campus, and this is the result. Okay, the first one is that we can say hello and they answer it about I'm a chatbot from ISTTS. But when we ask the Gemma into another task that not related to my university information, the Gemma was answered, I'm sorry, I cannot answer that. Okay, they already know about the context. Okay, and when we try ask about what is my university, they can answer what is, give some detailed information about this. And the second one is I do also the fine tuning with my team. Bill and Patrick, we try to fine tune the Gemma using some of local laptops. I use laptops with standard GPU, and we try to fine tune. We use the dialogue instruct model. So we are using the dialogue tune language model, which is we will have the prompt into several templates like this, the user and the model question and answer. Okay, and the first thing is that we create the context, we give the information, and then we create a question and an answer pair based on the context. And the third is we format into the Gemma template so that the model can be learned, and we fine tune the Gemma to answer our model. We use the LoRa and SFT trainer for fine tune the model. This is the example of the model of the context I created. Where this is my website of my company, and this is the second context, and we created a list here, and we format it into the question and answer for each context. So each context, let's say the website of my company, I created 2 sentences that ask, and this example of how they answer it. The Gemma should answer this question based on this context, and we format it. After we create the question and answer pair, we format it into the Gemma template. Okay, the first one is we create at the start of the turn the user, and we provided what is should be said by the user, and we provide the end turn and the start turn by the model, what they should answer by the model. This kind of template will be used by the Gemma to learn and create to fine tune the model. This is the example for the context 0 that I asked about my website. This is the instruction that I made, and I created the template for the Gemma. The chat template become like this. So the user, I create the instruction, I create the question, and the model should answer like this. Okay. Surprisingly, we use the quantized version of Gemma. We only use 4-bit quantization with the Gemma 7 billion instruction version, and we use LoRa and SFT parameter, SFT trainer. Before we get the fine tune, the information was completely wrong. Okay. After we get the fine tuning, they can provide the good relation based on the context that we given, but it's still not 100% correct. Okay, because the lack of data that I provide for this experiment, the result is not so good. Okay, but if you get a lot of data, then you can get a more better result. The third case was I tried to add some modality to Gemma. Gemma was not since Gemini is a multimodality, Gemma was not a multimodality. So I tried to add some modality to Gemma by I create Gemma to have a show and tells from the image. So I create using the same architecture with Mini GPT-4. We use the Gemma 2 billion instruct model. We create a vision model to create the token of our image feature, or we can say this is the image embedding. We put an image into a clip vision model, and we put it as output it as a token image. We put it and with the prompt to the Gemma, and we fine tune to answer to create a description of the image. We use a linear model as a remote representation, and we use the clip VIT for the vision embedding. And we use the Flickr 8 dataset. So surprisingly, the result is, I think it's very good. This is the image that I use from this URL. I just create a short poem from this, and this is the result. Okay. And the other one, we put a cute dog photos. And when I try to create a poem like this is. And we push the Gemma to create a recipe. Okay, I want to create the recipe from this image, and we can get the recipe. Okay. And the last thing, I want to create a song from this image, and we get the song. We only use one single GPU for this. Okay, so that's efficiency of Gemma and how powerful Gemma to support the open source language model development. Okay, that will be for my talk. And if you want to learn about the Gemma, please look at these details more further to have more detailed explanation regarding to Gemma. Okay, thank you. If you want to discuss for me, you can find it in here. Which one?
So in this journal, is that error have been fixed yet, or?
Okay, you asked about the Gemini was wrongly. It is controversial last time that this has been spread news. Okay, I answer that Gemma is not a multimodal language model, so it's only based on the character or only for this on the text language model. But when I try to accompany the Gemma to add some modality here, it's maybe wrong. It may be provide information wrong because we cannot ensure the Gemma performance since actually Gemma was not to create for the modality. But in my example last time, this is I tried to push the Gemma capability by adding some multimodality. But surprisingly, this is I created and got the good result. But if we provide another version of input, maybe it give a wrong description. It based on the, but yes, we need to tune our language model and we need to test several cases to prevent our model give a wrong answer. Okay. Okay. Yes.
And then you were asking it some questions and it was producing better results, but still not quite accurate.
Yeah.
Is that, you said behavior across all models when you fine tune, that there's that risk that they don't produce exact answers that mirror the training data?
Yes. Especially when we do not provide a large of training data. So if you only provide a small data like I use in my example, actually this is only, I use the context, the information only 100 context, and the place the data question answer pairs only maybe 200. I think it's not good enough to provide a good result. But if you give the model a lot of data training for the fine tune for this template, it will be give more accurate information. And you need a lot time to train again. Okay.
Okay, I guess that concludes this afternoon session. And I think there's a coffee break now, I believe. And then we reconvene here at 4 p.m. to continue our AI. Very interesting. I think it's a deep dive into the diffusion models so by Adobe. So I'll see you back here. Thank you. Thank you.
Good evening, ladies and gentlemen. My name is Ishan Dutta, and today I'm not here to give a talk. I'm just here to perform a bunch of magic tricks. I'm sorry, organizers. I'm not an AI researcher. I'm just a magician. I was looking for an international stage. This is the stage. You all have been pranked, and this is not an AI talk. Or is it? Am I saying the truth or not? To find that out, we have to go back a couple of years and listen to a story. 4.5 years ago, I was in my sophomore year of my college, that is the second year, and I got a call from someone at a very high rank at Amazon US. That was my day zero in AI, and what she explained me is the kind of algorithms and the kind of problems that they are solving at Amazon at the very core level with the help of AI. Throughout that 2-hour conversation on call that I had, I was left with one question. Is this magic? So you are telling me that I give you a bunch of data, you have something called as a model, and once that model is trained, you can predict things. And you can even predict things that are in the future. If that is not magic, what is it? Since the last 4.5 years, I have been on the quest into finding the answers of what is this magic? What are the tricks behind this magic? And who are these magicians? A brief introduction about myself. As of today, I work as a machine learning engineer too in the core generative AI team of Adobe India. Along with that, I have freelance contracts with 2 very popular startups. One is Lightning AI, and another one is a vector database startup called as LanceDB. I also represent Jarvis Labs AI as a global brand ambassador. Previously, I have worked with the likes of NVIDIA, Weights and Biases SF, as well as a bunch of research institutes like Indian Institute of Technology, Kanpur. I'm also a Kaggle Notebooks Master, top 70 in the world. And I have a bunch of top ranks in multiple hackathons. If you want to follow me on my socials, feel free to scan the QR. Introducing you, magician diffusion. Think of this example. Who is a magician? What is a magic trick? Any magician who is there, he gets a number of props. He learns to how to use these props in the best way possible. He iterates over that trick multiple number of times and gives out what is called a performance. If you relate it to the world of AI, those props are actually the data set that you're providing to the model. The model is actual magician who iterates over this data multiple number of times unless he understands what to do with it. And the kind of output the model provides is the result that is there in terms of magician, is the performance that you're going to see. Now, before we actually look onto what are these tricks that the magician diffusion uses to bring such beautiful outputs, let us see what are the outputs that we are talking about. What are diffusion models actually able to do? I have 2 examples over here. The first one is very popular text to image generation. We have a bunch of open source models now, and they are doing really, really good. These images are from DALL-E, by the way. A second very popular use case came out very recently by OpenAI, which is called as Sora. This is one frame generated from their text to video model. And the kind of now these tricks are what make the magic work. Every algorithm, you can think of it as a magician. Every algorithm has a bunch of particular concepts which it uses, which makes it unique, and so that it can produce a particular output. Today in this talk, I'm going to focus on 3 important tricks or 3 important concepts behind diffusion models, which make it work and make it get the kind of outputs which you saw over here. Before we go into the tricks, I will introduce you diffusion models, how they are trained, what they are, and a very brief overview. Then we will dive a lot deeper into it to keep the topic deep dive into diffusion models as it was originally. Now, in the case of diffusion models, think of it this way. I give you a perfectly good painting of a very beautiful view of Hanoi, right? And I give you a task that, let us say you have 10 seconds. Every second, you can pick a couple of colors and you can put a couple of brush strokes on that painting randomly. You do that for 10 seconds, 10 number of times. And at the end of it, you will have a completely random canvas with random colors because you have been putting random colors over it. In this case, in the first image that you are seeing, you have a perfectly clear image. In every time step, for now, let us take the analogy that every time step is equal to 1 second. This is the image at the 0th second. At the first second, I add some bit of noise to it. At the second, again, some bit of noise. We continue it throughout to t time steps. For this example, let us say we are running it for 10 seconds. So at the 10th second, we have something which looks completely like noise. In that kind of painting analogy, you have just random colors on the canvas. You cannot make out what it is. In the reverse process, what we have to do is that given this noisy image, I have to figure out a way so that I can come back directly to this good image. It's like you have a random color canvas painted, and you have to undo the entire process which you did. And from just some random colors on a painting canvas, you have to go back to a perfectly good looking picture, right? This is very straightforward. Pick an image, add some noise to it progressively. And then again, in the reverse process, the name itself is reverse process. You reverse the entire thing. Now, there will be a bunch of questions which will be in your mind. The first one should be, before that, I will tell you a little, give you some bit of mathematical notations. These will help us with a bunch of formulas that will be come up ahead. Now, if you are scared of math, don't worry. I will try my best to keep these things as simple as possible. Diffusion models has, I believe, the most amount of math any AI algorithm has had. I have derived equations, handwritten equations of over 200 pages and all, just to complete this entire presentation. I will show you some of those derivations, but not all of that is possible in 25 minutes for sure. So very simple, it's very basic. You have the original image. Okay, we represent images with the variable x. Since this is the first image, we are computer science engineers, we will give that a 0 and not a 1. So x0 is the first image that we have. We go for t time steps. In our example, t, yeah. If our example t, since we are starting with 0, in our example, capital T will be 9. Okay, so we go from 0th second to 9th second. In the 9th second, we have completely noise. In the reverse process, we are again starting from the completely noisy image. At the 9th second, we go back and reach the original image. That is it that we are doing overall. Now the tricks that are behind this, there are a bunch of them. The first thing that should come to your mind is that, Ishan, I'm adding noise gradually to it, right? Why not just pick an image, add completely noise to it, and then learn a mapping which can learn from generating image from that noise? Why do you have to go in steps? You can just learn one mathematical function which is complex enough that can convert any noise into an image. What is the need of going in steps? The second one is called as a noise schedule. So let's come back to that later. And the third one is called reparameterization. Now, most of these tricks are relevant more towards the forward process, okay, and the reverse process as well. To understand why we are taking steps, think of this example. Let us say you have gone on a vacation. Like for me, this is also kind of vacation. This is my first time in Vietnam. So I'm staying in a hotel. Now, I look for a couple of restaurants nearby to have some good food and some good Vietnamese cuisine. You guys have lovely food over here. Thanks a lot for this. And I find this restaurant, which is at the other side of the street. Okay. Now, there are a bunch of ways to reach to that restaurant. The first one is that I think of it that I am staying here. These are all roads, by the way, and I can reach somehow directly to that restaurant. Is this path actually possible? The one which I have drawn. Is this possible? Or you can just nod your heads if you think it is not possible, right? Think of it a second. See, this talk is also here to develop your intuition behind why these algorithms work. I have seen a lot of blogs, I have seen a lot of YouTube videos on this, and I have seen very few people try to give out intuition behind why things actually work, instead of just like putting out formulas that they are there. This is not possible, because if you think what makes you say this is not possible, it's your brain telling you that it finds no way to calculate a way that it can make you reach directly from that road to here, because there are corners, you cannot jump from here to here. So your brain actually calculated this for you and told you this is not possible. If I change this path a little, and I give you this path, so you are here, I give you step-by-step directions, you go straight, take a left, again go straight, take a left, and again go straight. Is this possible or not? It is right. Why? Because I gave you smaller steps, your brain is now able to calculate, okay, I'm standing here, I have to go there, then I have to take a left, then I have to take a right, and it is more calculatable by your brain. In terms of machine learning and statistics, we call this as tractability. Tractability is when something you can actually calculate using your machines. The last example was intractable. We cannot calculate away. This is tractable because we are going in small steps. In the case of our processes, that is the main reason that we are doing it. If I turn a completely good image into completely noise and try to go back directly, just without taking any steps, just in one time step, that is an intractable process. There is no way you can calculate something which is capable of doing that. That is the reason, and that is the first trick which magician diffusion uses. The second thing is called as a noise schedule. So when I tell you that I add noise in different steps, you might think of, okay, but what is the amount of noise that I'm adding? It's like if I'm giving you the painting example, you have perfectly good painting, and I give you one brush and a bunch of random colors. So how many brush strokes am I allowed to actually paint in every time step? Is it 5? Can I do 10 brush strokes? Can I just throw a bucket of painting on the picture, right? How many of it? So there has to be a way that we make it actually calculatable. The first authors of this comes from the paper, Denoising Diffusion, Probabilistic Models. The terms are very heavy, but when I break it down to you, it will be okay. Very, very simple. It's denoising because you're basically removing noise. Okay, it's diffusion, and we will come to that later. The first method that they came up was with increasing things linearly. So let us say I allow you that for the first time step, you can add 2 brush strokes. For the second time step, you can add 4 brush strokes. And you can go on and go forth till 20 brush strokes. And your graph will look something like this. Okay, it's a linear graph, you're linearly increasing it. But there is a very big problem with that. If you see this image clearly, so you have a dog over here, very cute looking dog. Until we are close to 40-50%, doesn't this already look like completely noise? It does, right? Is there any point of going from here to here? No, right? It's like when you're taking a Grab taxi, you have already reached your destination, but the driver wants to increase your fare. So he will just make you go circle round and round and round so that the fare increases, but you are actually at the same place. So that travel is not taking you anywhere, right? Because of that problem, the authors of OpenAI came up with a different paper, which is very critically called as improving denoising diffusion probabilistic models. Okay, and what they did was they came up with a cosine function, and a cosine function helps you with gradually increasing the noise. If you compare it picture by picture, you can see that the kind of dog that you can see here is a little more clear than the picture that was there. Okay, now this makes that step-by-step thinking even better for the model, and we are completely going to noise here. The major advantage of this was, in this case, the original authors had to take 1,000 time steps to reach that noise. With this method, you can do it in just 50 time steps. That's an amazing efficiency. So noise schedules are the second interesting trick the diffusion models use. Now remember, we represent noise schedules with the term beta. Okay, beta, because we will come to that later. Now to understand the third and an extremely important trick, which is called as the reparameterization trick, we have to understand the math behind diffusion models a little more. I know everyone might not have the same math background, and so I'm going, the formulas will be there, but I will explain it in a way that you can understand what that formula means instead of going like line by line what it is doing. So the forward process was this: you're just adding noise step by step until you get a completely noisy image, right? So this is how the forward process is represented. So if you have to give a variable, so at every time step, what am I doing essentially? Think of it like this. I have an image, I pass it to something, it adds some noise to it and gives me another image. Okay, that output becomes the input for the next time step, right? And so on and so forth, we are going till the end. This can be represented in this way. So at t, let us say t is equal to 3 over here. Okay, so t minus 1 is 2. I give the output, at the t at 2 seconds, okay, whatever image I have after adding noise at 2 seconds. And I want something, a process, let us say q represents the forward process. I will pass it to q and it should give me x at 3. I'm giving a previous image, I get the current image. So the kind of noise that we add is called as Gaussian noise. Gaussian noise is a very interesting kind of noise. I will show you the graph and why exactly we are adding it. But to understand this notation, this looks very big. It is extremely simpler. And the authors have made a lot of things constant, so you don't have to worry about it. To understand the notation, this is the actual symbol for Gaussian noise. I call it the stylish n. And you have x of t, the output. So if I am at t equal to 3 seconds, I'm getting t equal to 3 seconds output with the picture I had at t equal to 2. Okay. Now this is called the mean and the variance. So to understand what are mean and variances, let us say the average age of people in Vietnam here is 33 years old. Okay. What is the meaning of average or mean? Okay. Think of it a little more. Let us say I have a number line from 0 to 100. And you have divisions of 1 year each. Okay, 0, 1, 2, 3, 4. When I say that the average age of people in Vietnam is 33, it means that since this is a college, the number will be different. But in general, in the entire country, if I ask someone, there is a very high chance that they might their age might lie somewhere very close to that number 33, right? So if you imagine that kind of number line, you will see that a lot of points are actually concentrating close to that number 33. So that is the mean of a distribution. Everything in the world is a pattern. Your age, where you are coming from, okay, what you're learning, what you're reading, even your daily schedule is actually a pattern. And machine learning is all about recognizing those patterns. Okay, now that is the mean. Okay, you understand what mean means. Variance is basically how far does it spread. So if you think, let us say this is the number line, you have 0 to 100. And here somewhere you had that 33. Most of the points lie here. But how far do those points lie? Okay, that gives you a variance. If the variance is very small, most of the parts will lie close to the mean. If the variance is very high, most of the parts will lie very far from the mean. That is the kind. I will show you the graphs as well. But for now, this is the mean. Beta, I had told you the noise schedules that were there. So beta is the amount of noise that you are adding at every time step. T, okay, and beta t of I, this is variance. Anyways, this becomes constant later, so you don't need to worry about that for now. Now let us think of what is actually happening. So we say we are using the term Q to represent one step of the forward process. as defined earlier, x of 0 is the first original image that we have. We pass it to something, which is a forward process, to Q1, okay, and we get that image at time t equal to 1, and we do that n number of times, right? So it's like a function of function of function, finally till we reach Q of t, okay? That is that at Q of capital T we are reaching. Now, if you try to see this as just with one time step, let us say I'm at the first image x of 0, and I want the next image, which is at first second, okay? The formula will look like this. The output is x of 1. In the mean, we have beta 1 and x of 0. And in the variance, we have beta 1 of I. Okay. Now notice these two terms very carefully. I is identity matrix by the way. It is completely, you can imagine it as a diagonal matrix. It's completely ones. So it's a constant. Now if you go to the next step, where we have the image from the t equal to 1 second, and we want to calculate the image at t equal to 2 seconds, we have output x of 2. We have beta 2, we have x1 here, and beta 2i. There is a very interesting thing, and there is a pattern over here. Okay, the pattern is that these two terms, if you see beta 1 of I and beta 2 of I, you already know I. It's just a matrix, which a bunch of ones arranged diagonally. Okay, betas is something which we have already calculated because we have a fixed formula for it. So this becomes a constant. Kick it out. We are now just concerned about the mean. Okay. Now the authors added a bunch of more notations to it. I will tell you the reason why. Now, if I tell you that I have to go for 1,000 time steps, so every time I'm doing a training loop, okay, and let's say in this training loop, I am at the 500 second. So I have to add that noise 500 times to reach that particular output. Let's say in the next training step, I am at 500 first second. So I have, okay, so I have to add that, that number of times. So to solve for that, the authors came up with more notations. You can replace alpha t with 1 minus beta t, and you can have the product of all alphas from 1 to the last time t as alpha hat of t. If you replace that, okay, I replaced alpha t with 1 minus beta t in all of it. And finally, the mean of that equation was this. And you can just go to t minus 2, t minus 3. The final output which you will get is that alpha t bar of x naught. Now, what is the benefit of this? Is that now this equation is represented in this way. Okay, you see 1 minus alpha t is gone. This we will find out how to get it, but this is x naught. So the benefit of this equation is that now I can give this equation any t, because this is dependent on x0 only, and I can get the output. So if my training loop, let us say it wants the image at t equal to 500, I don't need to go for 500 steps. I have a formula which will give me the image at the 500 step. That makes it super, super efficient. Okay, but there is a very big problem with this. This is not, you cannot calculate the derivative for this. Okay. You will say that, wait man, you have been talking about Gaussian distributions, but if you can't use it, if the neural network can't use this to walk, it's like I gave you a path, but that path does not, you cannot go to that path. Okay, it's like, let us say you're trying to learn a new recipe. Okay, and I give you 5 ingredients from a shelf with 1,000 ingredients, and you have to learn to make a recipe. Now the way to go about it is that you try different ingredients, you replace 1 or 2 of them with different ingredients and see what works and what does not. If every time I'm giving you 5 completely random ingredients, will there ever be a day that you will be able to reach to the correct recipe or not? There won't be. Because you won't know that because of which ingredient, I am very far from that recipe. So that is the same thing which happens over here. If you are just pulling at random examples from the distributions, you won't actually reach anywhere. So what is the reparameterization trick? Is that if you have a standard normal distribution, okay, with a mean of 0. Okay, I talked about that graph before. There's a mean of 0 and variance of 1. If you see these graphs, all of these have been derived from this. Okay, how? You see, in these 3 things, in these 3 graphs, the mean is mu represents the mean, sigma square represents the variance. The mean is the same, 0, but we have just moved the variance. So it has become wider. Okay, if I have changed the mean from 0 to minus 2, it has moved towards the left. So what you can think here is, if you are actually adding or subtracting something to the mean, you can move the graph left or right. And if you are actually multiplying something with the variance, you can make it smaller or larger. So That is the final reparameterization trick that you have, where you can actually, you have the mean and you have the variance. You keep the mean as it is. And instead of actually using that distribution, you can just multiply something with the variance. So using just that one graph where you already know the mean and variance, you can find this as a product form. Now this is computable. Why? Because in this case, these are two random. Okay, you're every step you're pulling this randomly. This is like random ingredients that you are pulling for the food, and you are trying to process it. You cannot come back to it. But I have kept the randomness out of it. That is epsilon. So now this derivative can be computed. Okay. Now I think we are a little out of time. So I will, yeah, this is fine. I will give you a very brief. Okay, I will give you the very brief of the reverse process. What actually we do. Actually, we can just go directly to this one. Training and sampling, how that happens. Yeah, we have 2 minutes actually. No worries. Anyway, whatever tricks I told you, the same will be applied over here. In the reverse process, I had a bunch of formulas. But anyways, you will need the derivation for this. But the training algorithm is very, very smart. The training happens in actually 2 ways. The first way, you take an image from the data set that you have. Okay, you take any time step from a uniform distribution. Okay, any time step, I gave you a formula on which you can get the image from any time step that is possible. And you take epsilon. Epsilon represents the noise from a normal distribution. And then what the actual model tries to learn is that the noise which I have added, okay, can I remove that noise? So it is actually trying to predict the noise which was added in that time step and to try to remove that noise. That is something which is it trying to reduce. So it does that till n number of steps, okay, till it learns how to remove noise from that particular image and that particular time step. And in the final step, we have something called as sampling. So once you have learned a model which is capable of removing noise, then what you can do is you sample any random. So this x of t is sampled from a normal distribution. This is just random noise. Okay, you go from capital T towards 1, and you repeat it like till you reach 1. You have, and then using this formula, you can actually calculate how to go for the x of t minus 1. I couldn't cover that because of the time. Yeah, but this is it. And yeah, that's it. So training is basically you first train a model which learns how to remove the noise. And secondly, you use that model to pick any random noise and make a very clear picture out of it. Thank you everyone for listening. And now that you know the magic tricks, you can learn to start the magic. If you want to follow me on my socials, this is the QR code. Anyone has any doubts or questions, you can ask me separately. Sure.
Okay, thank you, Ishan. So this really technical deep dive. Okay, next we have Rohit from Red Hat.
Thank you everyone for staying so late. It's already like 4:30 after tea break. Everyone is here. Am I audible? Okay. All right. Thank you for who are here to attend the talk. So my next talk, so I'm an associate quality assurance manager at Red Hat. And this talk is mostly to give a brief introduction, like how QA testing can be used by in-house RAG model deployment. And why do I need to specifically use RAG? Because training of models is pretty difficult these days, and it's time consuming as well as it's expensive. So let's look into this, how we can use this technology to better efficiently do software testing. All right, so this is about QA reasoning and AI in action. Why do we need, when we talk about artificial intelligence, what is artificial intelligence? What is the intelligence over here? So it's more about using your knowledge and the actions which you perform by reasoning to solve a problem. The intelligence lies over there. But the large language models, which are generally building used by transformer, they are only for predicting the next token. So how can we use it intelligently to perform our software engineering task? We can use something like giving it a capability to perform some actions of it. We are not just creating some language, but we have to perform some actions out of it. And we can use the concept of agents by combining with the large language models by chaining it and giving a persona of a QA engineer. Like you have to think like a QA engineer. You can well train your templates, query templates or prompts to give the context with the query to get the output, resulting output. When we talk about knowledge, from where we get the knowledge, it's all about either the model needs to be trained or we need to provide the context to it. And when we say context, we need some kind of input source to it. That's why we use RAG. What is RAG? So RAG stands for retrieve, augment, and generate. So retrieve is retrieving relevant document from your source. Your source can be any backend database. Your source can be PDF document. Your source can be CSV files. But to retrieve it, you need some kind of backend storage so that you can just store it somewhere. And what is augment? Augment stands for query with context. So you have your questions, but you want to get an answer out of it. So you need to provide some context from which you can take the help of large language models capability of generating the next predicted token. And the generate here refers to the inference from the LLM. And what inference is, when you have to query a large language model, the process is called inferencing from a model. Why do we need RAG? Mostly it's for hallucination problem, which large language models do. It's not a bug or an issue with the LLM, but it's a feature of LLM because it is predicting the next available token out of the question or the best possible word which you are asking for. So if it doesn't have a context, it will just try to make up the things. So to solve that problem, you can use your in-house RAG to provide it a context, and it will help on the accuracy for the next predicted token which you are asking as a question. You get data privacy out of it because you are not sending your data out anywhere in the internet or training your model out of it. All your data is under your in-house or on-prem premises. You can trust the data source. You can, because it's quite faithful. You know the source of from where the data is coming from. Then also you know the retrieval time as well as residency. That means you can trust your data on the real time. Your backend database can be updated and you can have a real-time context querying rather than your old stale data on which your RAG LLMs are being trained, and it's a time consuming to train again on a fast moving application these days. So it's better to have a real-time data which is updated, and then when you put into the context of the query, you get the relevant answer and responses from it. You can also trust the source because it's just not a retrieval of the document, but also it helps in providing you the source of the document from where exactly the document context is coming from. And when we talk about RAG, we also need to think about what is the best possible retrieval method. We'll cover that in our next slide. So vector search is is one of the uniquely primed thing for RAG models. So before that, vector search, let's understand what exactly vectors are. So vectors are nothing but a large numerical array which stores the information about your text. It's all mathematics. And let's say if you have some point in a space x, a point A, which has a three-dimensional representation like x, y, z, you have the representation of that number. But in terms of text, when you define some word and you make a vector array for it, it has information of characteristic of that word. So a three-dimensional have only 3 specific characters. But when you talk about a multi-dimensional array, it has lot many information. And we are talking about vectors of size 386 dimension, 786 or 1024, 1586, 2000. So these chat GPTs 4 and all have a dimension of more than 2000. So you can understand how much information is being stored over there. And the process of converting your text into this numerical n dimensional array is called embedding. And the resultant data which you get, the embeddings which you get is also called as embedding. So both process and the resulting embeddings are called embeddings. So now think about what exactly is vector search. So vector search is like something when you have two text over here, and this is one of the plot which I have created from using matplotlib, and try to slice n-dimensional array to a three-dimensional model where I try to represent some words like, so let's say my database, the vector database has words like husband, car, shark, and I try to retrieve a value wife. So the next possible retrieval relevance document which I'll get with wife is husband. So it's directly connected with husband. When I try to search for Tesla, it will try to, and if my database has car, Honda, and bus, so it will try to find out the relevance document for Tesla, and it will show me as a result that car is a relevant document for Tesla and Honda and bus. This is not a keyword search, but it is a similarity search because it's trying to identify which is the next closest thing to your search query. So that's how you can do. And it uses like multiple ways to do that. There are usually L2 distance. That means it's try to calculate the dimension minimum distance between the two closest search. It has inner product, means you are just trying to find out the exact value, and then you have cosine distance, which is just like calculating the angle between which is the closest angle between the next predicted value. Okay, so coming more into this vector embeddings, I'll just take one more minute. What exactly the vector embeddings contain? So it contains syntax, that is what does the noun, pronoun, verb, adjective of specific details about the word. It contains the semantics, that what exactly it means. So let's say Tesla or car. So Tesla can stand for car. It can stand for magnetic flux density. It has many values. So these all information are being saved in these numerical values. It also understand about the occurrence. It also understand about the semantics and relationship. That means, let's say if I talk about what is FOSSASIA, and my embedding model, which I use for creating embeddings for my vector, has information about FOSSASIA. So once I do a FOSSASIA search, it might be the next closest thing would be conference, or probably it can be like open source conference, something like this. So that's how the relationship is being stored. So think about the information which is stored in a vector size of 2000 dimensions. I only know 4 dimensions after watching Interstellar, that time and gravity, but it's like 2000 dimensions. So you can understand how much information does a single vector contain. I can also show you one quick pgadmin database picture where this is the text. No matter how long the text is, okay, I'll just make it bigger. No matter how long the text is, you can create vector embedding for all text, and this will be a dimension of 2000 or whatever you give as your embedding requirement of max token length. Okay. All right. Once it comes about, once we have understood about vector search, let's talk a little bit about the reference model. What exactly the reference models are for which we are working on the QA point of view. So basically, when we talk about reference models, so think about a large language models are just for generating language. They are language generating machines. So when we talk about a text generator, or a text model, text generation model, it's just predicting the next possible token value or the next value of word which is closest matching to it. And when you query it, you are just going to get an answer for next token which is very near to it. So using so this is one of the model, like when you query your ChatGPT or any model, what it happens is like it directly goes to the ChatGPT for inferencing. But when you use a RAG model, it first checks the information from your vector DB. So you write a query, it will convert into the vector embeddings, because that's what it's trying to retrieve from the vector database. After that, you will get, after this step of vector DB, you will get some list of relevance document. You can use a re-ranker over there for another embedding model to get the most relevant document out of it. It will now regenerate into the template with query and a context. That means you are just now sending to your LLM models for inferencing a prompt which has a query as well as a context to it. Your LLM model doesn't understand English. It understands only token. And tokens are again a numerical representation of array. They are not the embedding numerical, but they are other numerical input. So your all token text is divided into numerical values, which is again sent to you for inferencing from the LLM. We only deal with the embedding layer of LLM when we inference from the value. We only deal for training, and for inferencing, we only deal with the embedding and the output layer. An embedding layer contains the vector dimensions for each token. So that's how you get information about vector thing. The other point is like attention layer. Attention layer are the hidden layers on a neural network, which are used to help to predict the next possible token. The output layer, once your inferencing complete, your output layer sends back you a token again, and that's been decoded to give you a response. There are few of the use cases from the QE point of view where you can use, it's for test case generation, searching. So test case generation can be used by using the capability of large language models. You can provide the context. You can configure your prompt in a way that it can be used to generate your test cases. I do have a demo for it, but I don't think so the time permits. Yeah, we can also use the re-ranking model for similarity search, where we can use it to we can use those similarity search mechanism to test tag. That means you have a database embeddings for your test cases, and whenever there is a new PR feature, it will just tag your test for the relevance test cases. User story code coverage, test log analysis, text execution, NLP, code coverage change, and using models to test the LLM response itself. I'll just take one more minute. There are different tools you can use. LangChain for inferencing with the models. You can use Hugging Face, where the repository of the model is. Agents, which you can use, which uses inferencing from the LLM to take the next decisions out of it. You can use PG vector and PostgreSQL combination for storing your vector embeddings. Jupyter Notebook and Langsmith and Arise AI is like observability tools for your LLM, where you can get more information about how to debug your LLM responses. I think I'll be missing this part because this was one of our application certification rack QE, where we have a Mistral model deployed, and we can use this model to generate test cases. So when I say test cases, my vector embeddings are being retrieved from my backend side, which is like I got a similarity search of my test based out of my documents, and these are the relevance document. But again, I need to send my LLM very selective data to generate. So I'll just use a re-ranker to prioritize what document I need to select. I'll configure my prompt in a way that, okay, write a test case for KDM test. This is the sample, and these are the documents that you have to use. So this is just for the demo purpose. And now I get as a question and the answer, I'll get the final test case generated over. So this is my final test case, which has been generated.
I think we have to.
Okay. All right, I'll just not do the agent part, but these are the reference which you can use for LangChain, Hugging Face, PG Vector, Arise AI, Langsmith, and Gina AI, which is one of the embedding tool. All right, thank you for staying so long, and stay connected. You can just scan. Thank you.
Hello, everyone. Thank you for coming my session. Today, my presentation is the time to start the text. I want to open my presentation and text. And let me introduce myself. My name is Hyunah Yoo, and I made IT seminar and contents. And I'm Women-of-Code Seoul director. Women-of-Code is global community for women in tech industry. And I'm organization TechSKR, and I'm interested in AI education and community. If you want to connect me, follow my LinkedIn. Today's agenda is what is the text and text in Korea. Next, simply I'm text 101. Next, ecosystem and future. First, what is text? Text is Python library for high performance numerical computing and large scale machine learning. Simply text is Python library for AI. And advantage of text. First, there are functions for machine learning engineer and AI researcher, such as automatic differentiation and parallelism. Second, text using accelerate, so save the money and time. Text compiler is very fast, so because you save time and money. Last is just joking. Text is new technology, so if you can text, you can become AI hipster. I'm heard question. It is better than PyTorch or TensorFlow. It is very difficult to answer. But recently now using text including. For example, do you know Glock? Oh yes, Glock is generative AI chatbot by XAI. Glock is use Haiku. Haiku is text framework. And Hugging Face and Google DeepMind use text. If you searching text on Hugging Face, more 10,000 such results appear on Hugging Face. And Hugging Face is making an Flex community week, so many people is using Hugging Face and text. And second, do you research AI text? Google DeepMind made text, and paper is text. For example, Google DeepMind paper, VIT, more text, NERP, or sorry. Palm is using text. Second, we are now, let me tell you, in Korea, text. Korea is, or many people is using AI, and the number of people is using AI after ChatGPT was released. And so this question is program research in Korea. What framework or library do you majorly use? Many developer, machine learning or mobile other developers answer so PyTorch or TensorFlow. It said here is not text. And it is Korean IT community from Facebook user group. It's TensorFlow KR is majorly biggest, and second, PyTorch Korean user group is 1.5K, because PyTorch Korean user group is discussed and popular Facebook group. Last, it is text. Text KR is have 164 people. There is many important people and great people. Next, I have Korean joking. It is Korean is a very small country, so it explains it through SF fandom, 10 of Star Wars fan, 10 of Star Trek fan, 10 of Doctor Who fan. It is totally 12. I think also in AI field. Next, if you can use PyTorch or TensorFlow, I think, do you want to try this? Next, I'm simply text one explain, but enough. I have done enough time to everything, so maybe on pages first text is autograd and XLA budget together for high performance numerical computing. And text is Formula API transports text and non anywhere. First text is NumPy style API, and second text is very important thing, automatic dispersion and parallelizing. Last is the code is the same for CPU, GPU, and TPU. It is very good. Text is likely NumPy. If you want to use text, import text and text.numpy as JMP. Two is very similar, but different thing is modify is very difficult. NumPy is simply you can change the argument, but text is not argument because text follow functional programming and text, if you have side effect, it is done. So if you want to change the argument, other have using their code. And second, text use sustain compiler. Another compiler uses this, but text is sustain time. JIT compile code at runtime for speed. If you use text decorator or text.jit. So text XLA used, text is XLI used, and just in time. We see this code. First outline is not use the just in time compiler. Second line is use the just in time compiler. This code text.jip. So 396 microseconds fast. And it is 3 is autograd. If you want to using automatic differentiation, text.grade. It is page. This page is pass. And next, it VMap. VMap is auto vectorization. If you want to VMap using text.vmap. First blue box is just for used for, and next green box is transpose the weight after and with text NumPy API. Last box is purple box is use VMap. 3 box output line we see it is purple box is very fast. Next, Lex. Lex is low level API than the text API. It is pass. If you use text, it is very important because text is functional programming, so you can remember pure function. It is always return the same result, give the same input, don't create side effect. It is very difficult. And Python emulator is making side effect, so it's very difficult. And if you tracking, if you want tracking, text make that text PR use. And next, if you when using text.jit, if there are semantic arguments, to use partial. It is used TensorFlow, so it used a lot. So remember, like I recommend remember. 7 is random number. NumPy is simply random.seed make the random number, but text is first making random key, but after split. It is because functional program and so wait, the can range side effect after you can control the testing environment. Next is stateless class. You can use text. You remember stateless class. You make stateless class. So Python use if you use machine learning, the solution is this explicit state. So you managed output. Sorry. Next is PyTree. It is instructor. Text used PyTree. PyTree is a tree structure that create Python object container. Container include list, dictionary, and tuple. Next, this is PyTree used example. If you machine learning, if you make text, you manage weight and bias, you can use the PyTree. And next, last, parallel evaluation in text. If you want to use TPU code, text not changing code, and it is PMAP compile itself to there is not need for text.jit or decorator. As the summary is, text has a very similar syntax to NumPy, and text register strength and sustain time and autograde. And PMAP and VMAP. If you want to split if you want to make a random number, or you remember split key. And next is using when using text as a neural network, you need to make it a stateless class. And when getting the gradient, you remember Py3, and text is functional program, so you need remember pure function. Be careful. The last is text ecosystem. Text framework is include Flask and Haiku. Haiku, we remember it. Important is Haiku is maintain now is maintain mode. So Google DeepMind will recommend Flex instead of Haiku. And if you want text for AI, Optext Optimizer, Alex, or Text Giraffe use. Actually, today's detail is very not good, so I recommend him YouTube channel. He but this YouTube channel is made YouTube video made in 2022. So now changed version. Be careful. But his explain is very good for me, better than me. Next, what will happen to Dex in the future? I think more research and papers and service using the Dex. And Keras 3 is multi-backend use the Dex. So many people is more like easily use the Dex. So I think Dex is very good API. So and I translate documentation into Korean and organizing XKR and actually writing a book about X with my friend. I want to you join us. Everyone can contribute to X. Let's start small thing. If you are interested in open source or code contribution, Dex is many tasks you can try. Thank you, listener, for listening my presentation.
Before we get started, and as we're settling down here, I'm going to invite you guys to actually join the conversation. Go ahead and scan that code, and in your words, describe what you think an intelligent assistant is. So let's see what you guys think. What's an intelligent assistant? We've been seeing all these talks the whole day. You're on a software. You kind of want to get some assistance, but you don't want to get assistance from, an individual. And if you have taken the poll, go ahead and raise your hand so I can see if what the responses are. You should be able to go to slido.com as well and put that poll in there. And then I'm just curious to see what you guys have to say. Has anyone taken it? Did anyone put some words in? All right. It should show up here. And if not, I should be able to pull that up. We do have around 2 or 3 questions here. Okay, good. So good. It is working in active time, so that's good. Make sure you hit submit so we can see something. I know it's, oh, there you go. A tool that automates tedious work. Great. So it's tedious, it's time consuming, and want it to be automated, right? So that's one response there. I know another person is at least trying. Is there a lag from when you submitted the answer to what you're seeing on the screen? There is a lag, you think? All right, okay, cool. Okay, good. There are 4 participants, so at least when the typing stops, we'll stop there. But let's see what you think an intelligent assistant is. All right, very good. Thank you so much for participating there. So something that understands ideas and can make
give you some advice, helpful assistance for mundane tasks. Great, great, great responses here. A good mentor, something that teaches you something, that makes sense, right? And then also a personalized secretary as well. All right, so we had 5 people. I will definitely put these results up for you, so continue to take this poll. Then the next question I have for you guys is, how important, we're talking about an intelligent assistant being kind of like a mentor, training you things, telling you things, teaching you things. How important is it for an AI assistant to be actually usable? Right? So let's rate some of these. 6 of you are in. I can see at least around 15 or 16 people in the room. If I can get more of you to participate, that would be great. We have very few questions. It's not going to be all about question taking. So go ahead and scan the code, give me your, so it's very important for kind of, it needs to be usable. If it's not usable, that makes no sense. It's going to teach you a lot of stuff, but it needs to essentially be. What about there are other things too. Apart from usable, there are other things too that comes to mind. So this is kind of like, I thought this was kind of cute, AI is getting so intelligent. It was in the news yesterday, we're all going to be replaced by AI very soon. And then if it starts doing things like this, that's going to freak you out, right? Like that's too intelligent. We don't want it to be so intelligent. We want it to be the right level of intelligence, right? In fact, there's this whole concept of being even usefully wrong. Actually, AI, that's still, we saw some talks about hallucination. We saw some talks about going through the process of training, things like that. So it's still, within the inference formation, it hasn't really gotten all the data points to give you accurate results. So it'll actually give you results that may not be accurate, but that's just enough to actually tell you, give you some information about how AI is thinking per se. Right? I know I'll need volume, and sometimes I'm trying to look at that. So apart from the training model and apart from, limitations in your data algorithms and any kind of training as it's catching up, whether you're in the process of testing, there's one thing that can actually cause us to reduce our trust, and that's poor design. And that's what we're going to talk about today as well. So I'm just curious if I'm talking to any designers in the room. I know there are lots of coders in the audience. Anyone who designs AI solution, and by that I mean the actual interface. So it's not so much you creating that algorithm. It's not so much you, kind of giving the AI the questions that it can answer, but actually designing that interface. Anyone here? All right, cool. We have 8 people, 4 of you. Well, it's growing. All right, more people designing AI solutions, great. All right, so around 55, 45 kind of mixture, which is great. All right, so, and the reason I asked that is, tell me if you're a designer or a developer. Are you a developer designing? Are you a designer writing code? Which we do in open source. Honest here. All right, most of you are developers, great. So no designers. It's also good to know who I'm talking to. We see a lot of good design being generated by developers. I'm not discriminating here. Anyone else? Anyone who's not a developer here? We have 67. And I think I can scroll down because 30% has to be somewhere. All right, cool. So we have some PMs here. We have people in the community organization, things like that. So that's good to know who I'm talking to, the predominantly designer community. All right, we have a dedicated predominantly developer community. We have a dedicated design team, and this is what they do. So when you think about our design process per se, right? We have a lot of solutions that come up with, especially when we're designing for AI. This is our product management lifecycle process, right? You start, and then I'm a researcher. I'm a senior researcher at OpenSearch. We start with a lot of discovery work. With AI, we really got caught in like a storm overnight. It's not like OpenSearch cannot solve for AI solutions. In fact, we have different ways in which we solve for it, but given ChatGPT, given the whole, the way AI kind of blew up, we started to run really fast. So this discovery process, we did do it. I'm actually going to sprinkle this talk with a couple of findings there, but it was not in the true sense of taking that discovery of, there is a consumer need, let's take that, and take that to product development. We took that and we started using what we could, but we didn't do the classic ideation process. The second kind of bucket here is where you do rapid ideation. If there were designers here, they'd be very familiar, and perhaps you guys do too. Just show of hands. We didn't do a poll for this. Anyone familiar with Figma here? Have you used Figma? Yeah, for your UX and stuff, you'll use that, right? So typically you work very close. And now that you have Figma, FigJam, things like that, you use that quite a bit for ideation and also get the user involved in your design process as well. And and this happens side by side as engineers are testing their models, writing the algorithms, curating their solutions. On the front end, we are doing this stuff. And finally, you have this kind of evaluative. We're not yet there because we're still designing solutions, but evaluative is more perceptual, asking users, this is to solve the problem that you wanted it to do, or these feature sets, functional, useful, so on and so forth. So for this talk, we're just going to focus on the second part, which is ideation and ongoing improvements. This involves rapid prototyping, a whole host of mixed methodologies as well. And when you think about that design element, remember early on I told you when looking at the front end of AI, right? You're not talking about actual accuracies or reliabilities. While that is useful, what we are talking about is when you evoke AI, when you're calling AI, when do users want to talk to that AI model versus, say, I know what I'm doing, leave me alone. Persistence, where do you want to see your AI assistants? And then also we'll talk a little bit about icons as well. So here, remember I told you we did some discovery work, and this is something that I've spoken about at length in other conferences as well. But just this survey here is one in which when we asked them, this was very early in the process. We asked them, like, what do you want to do? Do you want to see the AI persistent all the time? Do you want it to come and go? And what was interesting here is it depends on the user type. You guys, most of you, kind of self-identified as developers. There are groups of people. So for those of you, let me also do this. I never asked this as well. How many of you are familiar with open search? Okay, cool. So because I'm assuming you're developers and you use open search, you're doing a lot of stuff that we call you as a persona type to be producers, right? You're wiring the data, you're writing your queries, and then you might create some visuals and put it on a dashboard, right? So when someone just comes in, reads the dashboard, does a query, they're consumers. You're more in the producer type. So when we have these two different personas, asking them when they would evoke what and why they would use AI, we're kind of different in terms of what they indicated to us. And then we have kind of like that split in terms of how many of them wanted it to be persistent. It's also really task-based as well. All right. And then I'm somewhere, all right. I hope it's not 30 seconds. All right, 5 minutes, we can get it done. All right, cool. And then we also asked them, how would you want to evoke it? Whether it was a button, a chatbot. As you can see, it's all over the place here, but predominantly people wanted to see a button. And then they would also like kind to ask for relevant documentation, do search queries in natural language, things like that. So there's all that past research there. One of the things our designer wanted to test is in terms of the icon. I'm going to see if I have volume. If not, I will talk over this. All right. I don't think we have, all right, we do not have volume, but I will talk over it. Essentially, the user is right now testing what we're offering them. There's this little icon on top. We ask them what they think about it. They'd be curious. They expect a tooltip or a pop-up to show up. And so I think in this particular thing, we actually walk him through that particular icon. They go ahead and click on the icon, and then they see what they're seeing. They see a generative AI kind of dialogue show up. It's not a drop down, and then they didn't expect to see these suggestions here. That's what our designer offered them. Like, these are very popular kind of like formats in which you say other people have asked these questions. It's also training them on how to use your AI, your assistant as well. And then after consideration, the user actually talks through this and tells us how he does find it to be useful and things like that. All right. So now I want you guys to rank order these things. As we did usability early on. We asked you how usable you want it to be. Go ahead and tell me about accuracy, reliability, speed, and meaningful answers as well. And as you're doing this, I'll tell you where we're coming with this. Our engineers, our developers focus a lot on accuracy and reliability. Something that is less thought of is actually meaningful answers. Some of you talked about inference formation and the complexity of inference formation and how that interferes with the coherence of what that model is putting out. That's exactly what we're seeing here. When you show, and especially when it comes to high code developers who are doing query in natural language, and the information that's put out is not meaningful, that's not very useful at all. So yes, so while we started off initially saying reliability, accuracy, and speed are important, eventually we got down to actually having meaningful solutions, which means our models need to be more complex from a semantic search perspective. All right, and then I did ask about this. This is more for me to tag who you guys are. So most of you, this is an AI track, so it just makes sense that you're designing for these solutions as well. So thank you for that. And as I said, this is the last question in the series, like I promised. All right, so what I'm going to do next is show you in terms of, we actually showed them this particular design. You can see there is a main, this is what they're doing. For those of you familiar with OpenSearch, they are running their queries and looking at the logs here. And then they have this model in which they're talking to that AI. Again, I don't think we have volume, but essentially this particular user talked through how the responses would be relevant. And then they were talking about the primary screen. So what they're seeing here needs to be relevant to the actual tasks that they're doing. And then they were talking about other kinds of, like, you know, if they saw something up here and they asked a question up there, that would be more of a global search, where something in a conversational style would be more in terms of that particular search that they were doing right there. Right? And again, it's very useful to see what the users say. Back to that survey we did initially, you see a lot of anchoring of the location. You know, people wanting to customize open to location, very firm about having the location of that assistant on the left, right, top, bottom, so on and so forth. And then also the format of the interface, whether it needed to be primary format or secondary format. For people who are writing queries, when they write queries in SQL, PPL, all that, they actually prefer to have that as that main window, but then they want to see how that query updated to make sure that the AI actually did make some meaningful change. And then other things that were interesting is the nature of communication. Most people assumed it was text. Very few people assumed it was voice. And then also when we asked about the style of language, most people wanted it to be natural language. Keep in mind, these are people who are coding day in and day out. If they needed some formal language, they just go to their own language. So that's kind of was telling there as well. All right, and then this one I'm not going to talk through because that's a summary. Just to summarize, do test iteratively. This is just a sample of what we've done. Definitely use rapid prototyping and also consensus. And with that, I conclude the talk, but I will leave a slide on some of the useful tools you can do in testing. And if you have a question, happy to take that in as well. And thank you so much for having me.
Okay. Thank you so much. So I think we've come to the end of the AI track. Let's give ourselves an applause. So you are all now AI experts.